Boys! What's up with y'all, boys? We are live! We are live! What's up with y'all, boys? My boys! Boys! What? My boys, let's start!
I can feel you everywhere, like a shadow, like a fever. Looking for a getaway, no escape, I'm going deeper. I can't fight my way out, I can't fix my broken heart. If you could only let me go, our love turned into a war. Not the start, I ain't coming back. If I've been or lose, I don't even mind. Oh no, I don't mind. Set me free, let me follow. Trapped inside, I can fight anymore. Let me be who I was before. I'll be better alone. Set me free, let me follow. Trapped inside, I can fight anymore. Let me be.
Alright, y'all, so you should be able to hear me now. Okay, guys, so what we gonna do now? Welcome. Okay, so okay, also we got some problems prepared. So the stream, like usual, the stream ends either when I go through some of these or when we hit the 1 hour mark. So yeah. Okay, so we're gonna start. So the first one, yeah, I got some problems ready for y'all. So this is the first one. Okay, so let's. Oh, I didn't open the paint. Then open the paint. Okay, so the first problem is code forces this one. It's this one. So this is the current problem. Okay. Alright, first problem, let's look at it. In an ICPC contest, balloons are distributed as follows. Whenever a team solves a problem, that team gets. Oh, hold up, I need to hide this for a bit. Just wait a sec, y'all. Wait a sec. Just a second. Okay. Okay, and okay, it's back. Okay. In ICPC, balloons are distributed as follows. When a team solves a problem, that team gets a balloon. The first team to solve a problem gets an additional balloon. Hold up. Gets an additional balloon. A contest has 26 problems labeled A, B, C, Z. You are given the order of solved problems in the contest, denoted as string S, where the ith character includes that problem S of I has been solved. No team will solve the same problem twice. Determine the total number of balloons that the team received. Some problems may be solved by none of the teams. So, yeah, we get our test cases. We get this is the length of the string, and then we get the string. So, what is the approach here? So, as we can see, when we get the letter for the first time, we're gonna add two to our answer. So this is gonna be 2 and 2 because we're getting A for the first time and B for the first time. And this is gonna give us 4, and then we have A for the second time. So that's gonna give us 4 plus 1, which is 5. Here we have only one letter, which is A, so that's gonna be 2 points. So we add 2 to the answer, and that's just 4. Here we have 3 letters, and all of these are appearing only once. So basically for the first time, so we have 3 times 2, which is 6. Here we have B is appearing first, that's 2. Then A is appearing after it, that is 2, so 2 plus 2, 4. And then we have 3 more A's, which is another 3, so that's 7. And we get 7 here. Then we have B, K, P, T. All of these appear once, so that's 4 times 2, that is 8. And then, yeah, we then have 17, which is from this one. So what is the approach here? So the topics are data structures and implementation, and one data structure we can use to solve this is a map. So we're gonna keep, actually I don't remember if I explained this already, but whatever. So one way to solve this is with a map. So basically each time that we encounter a new character, we will just make an entrance for it in the map, and then we're going to append 2 to the answer. We're going to add 2 to the answer because we encountered that character for the first time. For example, we encounter B for the first time, we're going to add 2 to the answer and add B to the map. Then we encounter K for the first time, we're going to add 2 to the answer and add K to the map, and so on. If we have encountered a character for the second time, we are just going to add 1 to the answer. So so for the first case, so for the case where it's ABA, we're going to have our map, and then so if M of character, so basically if we already have the character in the map, we're going to do ans plus equals 1. We're going to do our answer plus equals 1. Else we're going to do our answer plus equals 2, and then we're going to do M of character, and that's gonna be equal to 1. So we add that character to the map, and that's how we keep track of the characters in the map. And yeah, that is basically what happens. That's kind of about it for this one. This is ICPC, and we can look at the code. So this is the code. So we get the test cases, then we get the size of the string, then we get the string, we make a map with key, the letter and value, how many, basically just okay. So basically we are not gonna increment the count of the letter when we find it again. We are just going to add 1 to our answer. So as we can see for the ABA example, what's gonna happen is we're gonna encounter A for the first time. So that means that A is not going to be in the map, and then we're going to add 2 to our answer as we do here. Okay, we're gonna add 2 to our answer, and then we're going to set a character, a key and value for that letter in the map. So the key is going to be A, and the value is going to be 1. So in the first iteration, our key is going to be A, and the value is going to be 1. Okay, so that is the first, because we are going through ABA. So if M of character, we're gonna answer. Otherwise, we're gonna answer and do M of character. So that is basically what happened here. If I can twist this or something, like, yeah. Okay, so then we have then the second character is B. So again, we're going to add B with a key of B and a value of 1. So again, we have found a character for the first time. So we're going to add another 2 to our answer. So right now our answer is 4 because we have added 2 twice. And then finally we get A again, which A is already a character. A is already present in the map. As we can see here, we have, so first it's A, we insert A. Then it's B, we insert B, but then we get A again, and A is already present in the map. Okay, and that's why we're just going to increment the answer by 1, and our final answer is 5 for this case. Okay, and that's why we get this 5 right there. Alright. Okay, I think that's about it for that one. Okay, so that's about it for that one. We went through that one. So next up is lead code palindrome number. Okay, so right now it is, it's gonna get rid of all of this, and then now we have, now the problem is lead code, this one, lead code 9 palindrome number. So I have solved this using a string, and you can solve it also without a string, which is the follow-up question, but I'm not, I haven't really looked into the most optimal approach here. I'm going to show you maybe a more naive approach, but it gets accepted. So if that's what you want, then that's good. If not, I guess I don't know. Okay, so given an integer x, return true if x is a palindrome, and a palindrome integers is an integer that reads the same from forward to backward. So 1 to 1 is a palindrome because forwards is 1 to 1 and backwards is 1 to 1, and 1 to 3 is not because forwards is 1 to 3 and backwards is 3 to 1. And yeah, basically that's about it for the statement. So you can solve this by converting x to a string, as we can see, because you solve it without converting the integer to a string. Well, we're not going to look at that. We're just going to look at how to solve it with a string. So basically we convert it to a string, and then we keep 2 pointers, or just 2 indices. The first index is going, the index of the first variable is going to be at the start of the string, and the index of the last one is going to be at the end of it. And then if at some point we encounter a, so basically if the at some point, so let's say we have 1 2 3, then I is equal to 0, which means s of I is equal to 1, and then j is equal to 2, which means s of j is equal to 3. So in this case, we can see that s of I is not equal to s of j, so we'll return false. Otherwise, we'll increment I and we'll decrement j. And if we basically, if they cross, if I becomes greater than j and j becomes, yeah, if I becomes greater than j, basically if they cross, if they overlap each other, that means that we have a correct answer, and then we're gonna return true in this case. Okay, you guys can't really see. Okay, here, hold up. Make this a little smaller, maybe, or something like that. Maybe something like that, and put it like more to open on it. Put it like more to the side. Okay. Okay, so yeah, okay, and we return true, and we can submit this. It should pass. And as we can see, it does pass. So runtime beats 50%, and memory, well, not that much, but runtime is good. So that's a way to solve this, and that's it for that one. Okay, I actually didn't write anything on here. So that's it for that one. So the next one is also relatively simple as well. So we have this. You are given This one is a code forces one. You are given four distinct integers A, B, C, and D. Timur, Will, and three other people are running a marathon. The value A is the distance that Timur has run, and B, C, D correspond to the distance the other three participants ran. Output the number of participants in front of Timur. So basically, we just need to count. So basically here, as you probably already saw, we just need to count how many of these B, C, and D, how many of these are greater than A. So as we can see right here, we have A, B, C, D. B and C is greater than A, so that's 2. Here we have A, B, C, D, none of them, so 0. Here we have 500, 600, so 600 is greater than 500, that's we get 1. And here we have 3 of them which are greater than 0, so that's 3. And yeah, I said it here for the first test case, there are 2 people in front of Timur, specifically the participants who ran distances of 3 and 4. The other participant is not in front of Timur because he ran a shorter distance than him. For the second test case, no one is in front of him. For the third test case, only the second person. So yeah, we can look at the code as well. If it's okay. I mean, the code is simple. You just get the test cases, you get the integers, and then we use these and we increment the answer, and then we just see out the answer. And that's pretty much it for that one. Okay, we're going to the next one. Next one is, so we're gonna do this. So this one is valid palindrome. So we had palindrome number, but now we have valid palindrome of a string. So basically it's kind of the same as the string, but this time we have a string. So as we can see, we use the 2 pointers approach again when checking for the characters from the front and back if they're the same or different. So the statement is, a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters. So basically, after removing all, so alphanumeric, that is basically the alphabet, and also numbers, and also digits, or numbers, or whatever, or something like that. So yeah, that's why we also check if this is a number. We have a number. It reads the same forward and backward after converting it to lower or uppercase letters and into lowercase letters and removing all non-alphanumeric characters. It reads the same forward and backward. And I'm actually gonna try to draw this out kind of for you guys when this one. So maybe if you guys are seeing this for the first time, I'm gonna try to draw it out like right now. So given a string, return true if it's a palindrome, or false otherwise. So when we convert everything to lowercase, the letters, and when we remove all non-alpha numeric characters, we get this, which is a palindrome. Then we get this, which is race a car. That's because Raka if we come from here, it's race a car, then it becomes rasa a car, so it's not a palindrome. And then this one it's an empty string, but it's the same forward and backward, so that also counts. And what is the code? Well, basically we're gonna modify the input string, and we're gonna basically if there are any if there are any uppercase letters, we're gonna convert them to lowercase. Also, we're gonna add only letters and numbers. We're not gonna add any commas, colons, periods, semicolons. We're not gonna add that to the modified string. And then at the end, this is how we check if the string is a palindrome after converting it to a correct string. Okay, so let me get the I'm gonna get the problem statement. Like, oh, actually no, because no, I gotta use print screen. Gonna get the problem statement, and then I'm gonna okay, we're gonna get rid of this. We're gonna paste this. Okay, so at the end, let's say we have case 2 where our string is this. Okay, so let's say we have example 2. So example 2 where this is our string after converting it to a correct string. So this is our string. So we have basically strings, you guys know they can be modified and they're indexed like arrays. So that is why we're going to set one pointer called L at index 0. Then we're going to set called L at index 0. Then we're going to set another pointer R at the s dot length minus 1. Okay, which in this case R is equal to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's gonna be 7. Okay, and then we're gonna have our while loop while L is less than or equal to R. Okay, and then on each iteration we're going to check if the character at that index does not equal the character at the index from right. We're gonna return false. Otherwise, we're gonna increment and decrement. So let's try to kind of dry run this. So on the first iteration, s of L is equal to R, and s of R is also equal to R. So in this case they're equal, so we're gonna say L plus equals 1, and then we're gonna say R minus equals 1. Okay, so this is the first iteration. So right now we're on the second iteration. So now s of L is equal to A. Oops. S of L is equal to A, and S of R is also equal to A. Okay, so we started at 0 and 7. Right now we're at 1 and 6. So this is 1, this is 6. Okay, and right now they're the same again, so we're not gonna return false. All right, so we're gonna say L plus equals 1 again, and we're also gonna say also R minus equals 1 again. Alright, so actually I'm gonna write it here because I'm right here. So then we get S of L is going to be C, and S of R is also going to be C. Okay, so this is 0, 1, 2, and this is 5. 0, 1, 2, 3, 4, 5. So again, they're equal again, so we're not going to return false. So we're going to again say L plus equals 1 and also R minus equals 1. So now they are 3 and 4. So 0, 1, 2, 3. 0, 1, 2, 3, 4. And now though, S of L, S of 3 is equal to E, and S of R is equal to A. So they're 3 and 4 now. So 0, 1, 2, 3. So this is S of L and this is S of R. So they are different, and now that they're different, we're gonna return false because that means they're not a palindrome. And otherwise, in the case which, such as a case which is the first case, we're gonna go through all of the characters from front to back, meaning without returning false. And in that case, it's just left to return true. And I can submit this again. And it does pass. Alright, so yeah, that's it for that one. Hello, hello. What is? I'm not. I'm not using MS Paint as ID. I'm just drawing inside MS Paint. I'm just drawing inside it. What is it? Hello, hello, everybody. Welcome. So yeah, that's it for that one. I mean, MS Paint is one of the best IDs, though. You gotta admit, like it's almost as good as Word and Excel. Anyways, yeah. Next one is length of last word. Okay, so we're gonna delete this. So given a string S consisting of words and spaces, return the length of the last word. So the length of the last word in the string. A word is a maximal substring consisting of non-spaced characters only. Okay, we even have a definition of what a word is. So here we have this, the last word is world. Here the last word is moon. Here it's joy boy. Alright. And that's basically the statement. So what I have done is so how I solved this by doing this. So I made an array where I'm going to store the words. Then I made this is basically going to keep track of one word. So basic, and we're gonna loop basically through the whole string S. And every time we encounter an empty space, if if this has any length, so basically if this is 1 or 2 or 3, this is gonna come into this. So that means we have found a word basically, and we're going to append that word to the words array, and then we're going to reset the string back to empty because so we can add the next word. Otherwise, we're going to append a character to the word. So each time we encounter a space, we push the word, and otherwise we just append to the words. And also it can happen that after we have finished this loop, there still is a word which has not been added to the words array. So we're gonna add that word as well, and then we're just gonna return the final word in the words array. From behind. Hey man, I don't. I mean, I don't. As I tell you guys, I am not a master in DSA yet. I am just sharing what I'm just sharing how I'm just sharing my solutions, and I'm just sharing like my stuff. So okay, that's okay. So okay, so that's it for that one. I think that's gonna be for that one. We can go to the next one. We can go to the next one. So this one actually is not. This one actually is not a. I started coding with HTML, CSS, JavaScript. I finished. What should I do now? I mean, depending on what you want to do, if you want, first you gotta pick if you want to do front end, back end, or full stack. And then when you pick, if you want to do full stack, I think the next great step would be to learn React. So the next great step would be to learn React. Okay, bro. Don't, if you keep spamming, I have to, please stop spamming. Okay, I'm gonna put you in timeout because you're spamming. So okay, next. So this one is not actually a lead code problem or a code forces problem, but it's something useful. C++ not H, but it's something useful. So this is how to count the digits of a number. So we're gonna count. Okay, so we're gonna have count digits of n, and we're gonna keep a counter, and then basically while n is greater than 0, we're going to append to that counter. We're going to increment it by 1, and then we're going to divide n by 10. Then we're going to return the counter. So basically, we're going to look at an example in a second. So let's say n is 1, 2, 3, and we should get 3. Should get 3. Okay, we do get 3. So so we got count digits of a number. Count digits of a number. And basically, while this number is greater than 0, we're going to divide it by 10. So in the case with when n is 1, 2, 3, so we're going to check. We're gonna check. So it's gonna be while n is greater than 0, and then it's gonna be, so first it's 1, 2, 3, so it's greater than 0. We're going to increment the counter by 1. Alright, and then we're by saying it's gonna be n equals n divided by 10, which is the same as basically this is 1, 2, 3 divided by 10, and this is going to give us something like 12.3 or something like that. I'm pretty sure, but in C++, when you divide by 10, when you do this, with an integer, you get an integer. So we're gonna get 12. All right, and that's the first iteration. That's the first iteration. Actually, equals 2 by. How do you build logic? Please guide me. I mean, in order to build logic, you you need to just solve more problems. You need to solve more problems. Okay, guys, this is gonna be the last one for today. Okay.